Here we go. Whoops. Okay, welcome to Redwood Energy's Energy Modeling Workshop number 5. Right now, or today, we're going through CBECC-Res, but under the hood, and how to use the California simulation engine, which is underneath CBECC-Res. So, the general format of how CBECC-Res works, there's different levels to the code. First, from the very surface level, which was Energy Modeling Workshop number 4, we learned how to use CBECC-Res from the surface level. And then in this workshop, we're going to go into how to use the California simulation engine, which is basically a text-based code that controls CBECC-Res. Or it's like the engine that does all the base calculations and then feed that information back into CBECC-Res. And then CBECC-Res does some different calculations, and I can explain that more. And then underneath the CSE, this text-based code is the actual source code, which is in like C++. In later workshops, we could go into that, but I don't know how relevant that is to the audience, so we can talk about that later. From now on, I'm going to be saying CSE a lot, and just know that means the California simulation engine. So CBECC-Res, this is what it looks like. You have this building tree where you specify these different items within the house. CBECC-Res has limited inputs compared to the CSE. Basically, the different controls and assumptions are built into CBECC-Res for compliance. Like, for example, set point temperatures, and CBECC-Res limits you to how many floors you can have. And then you can use this for compliance, and it generates output reports. So basically, if you're trying to get a building compliant for code, you can use a very surface level of CBECC-Res. It'll tell you, okay, your building's going to comply this much, and all that good stuff. So it compares your proposed model, which is what we input here, and then to different rules, which are within CBECC-Res, and it gives you your compliance level. So basically, it has your proposed model, which is what you build here, and then it compares that to a standard model, which is the baseline code compliant model, and then that gives you your compliance level. And then in addition, it also calculates TDV and your carbon emissions for your building. And then TDV is an energy metric used in California that basically rates, or it weighs energy use at different times. Yeah. So then the CSE, this is an example input file for that. It's a text-based language, which means that you can actually kind of read basically the parameters that you're putting in. It's not like C++, where it's the different things that you type out aren't as readable, I guess. So as you can see, the define statement here, it's kind of self-explanatory, or defining something. And the CSE is a general building simulation model, as opposed to CBECC-Res, which is unique to California, where it's comparing your model to those building codes that we have. So in the CSE, in this text-based format, you can basically have any building that you want, and it's not going to compare it to those building standards. So because of this, you have more control over the inputs. Like, for example, you can change into the different set point schedules that you have, like your thermostat temperature, or if you want to change, I don't know, the power rating of your lights, or I don't know, different materials, for example. And yeah, we can go into that a little bit later. And then again, you can't, so you can't use this for compliance. It's general purpose research. Its purpose is for research. And then here's a link to the CSE user manual as well, which basically defines all these different all these different parameters that you can use within the model. And then the source code, this is just like a snippet example of what it looks like. This is using Visual Studio, which is a free tool to view and compile the code. And it's typically used, it's kind of a cool software. Like I said before, it's written in C++. And the way you can access the source code is basically downloading it from online, which makes sure you have the latest version of the code, as opposed to downloading it from the Bruce Wilcox website for CBECC-Res, which are the latest release versions. So yeah, we're not going to go too much into that, but I just wanted to show you what that kind of looked like. So some general notes about the CSC. Like I said before, it's very flexible and has a lot of capabilities like calling and printing out specific variables, doing calculations within your results and within the CSC. And then you can specify output tables and files that you want to output after the model, which is cool. And the CSC user manual, like I said, has a lot of good information. You'll need this to make changes to the CSC. And again, editing the outputs and inputs of the CSC can't be used for compliance. CBECC-Res has those built-in kind of filters over the CSC to make sure you're staying within those approved variables by the CSC. Like for example, I went to a workshop about how to use the CSC, and turns out that brick as a building material is not actually within those approved parameters by the CEC. And it's something that you would assume is very baseline, and it would have that, but as an example, you can't go into the model and make brick as your outside surface. You have to use what the CSC has approved, which is the California Energy Commission, for those who don't know. But yeah, it's an example of that. Some other general information. Said before, the CSC does calculations for CBECC-Res, but you have to use CBECC-Res to create these inputs and outputs from the CSC. And then, so kind of the argument for like, why do we even want to use the CSC? For example, you can change those parameters like I was talking about, and then comparing it to some of the other tools available, which you may or may not know of, but Energy Plus and Do2 are two other similar text-based languages that you can do building simulation with. So it turns out it's faster than Energy Plus, and it's more accurate for radiative and convection than Do2, has a more complicated like air transfer model within it. And it's used specifically for California, so if you're in California, it might be useful to look at the CSC. So why not use the CSC? It has limited HVAC systems, and there's no shading of opaque surfaces yet. But what I've learned from looking into the CSC and CBECC-Res, it's all open source and available to download. And it does change every so often as the building codes change and as they update and make it more accurate. For example, the shading, they're currently updating the HVAC systems, but it takes time. So different versions will have more updated things like that. So now going into how do we use the CSC. So first you want to go into CBECC-Res, and then you run the model. And then after you run the model, this creates that CSC input file. So you go into that folder, you check it out, and after that, after CBECC-Res generates it, you can either change it by directly changing that CSC language within that text file, or you can use an include file. And that include file, you include it through CBECC-Res. So you can access the CSC language through CBECC-Res using an include file or directly going into that CSC file. And so there's two different ways you can run that CSC input file not using CBECC-Res. So you can use the CSC launcher, which is provided by Big Ladder. So just a little program that they made, or you can use the command prompt on your computer, and basically those are the similar ways to do it. Feel free to ask questions throughout too if I'm not making any sense or any of that. So this is an example of those output files I was talking about, and I think I showed you in the last workshop that we had. So for example, CBECC-Res outputs this first block up here, and then the CSC within this folder that CBECC-Res outputs has all these files as well. So I'll show you what that looks like just as we go. So I have just this folder with one building model in it. The .rabd is the CBECC-Res extension. I'm going to open CBECC-Res, start with a blank project. Open it up. And then once you run it, it'll generate all those files. So also important to note, I should have said this earlier, we're using CBECC-Res 2019. So this is a version that's currently only available for research purposes only, not for compliance. Again, it's still being updated and it'll come out with a new 2019 code. And then it'll be used for compliance. But it has more features. That's why we're using it, like the include file, like I said. So that's why we're using it. And then, so the output is kind of interesting to look at. It has compliance summary, and then it has CO2 emissions, which is new compared to the 2016 version. And then some of the same information as before, like the energy use details and your percent compliance. Okay, so I ran the model, and now I have all these outputs in this folder. So the CSC files are within this folder here, the comp19. So I open it up. I have all these files that the CSC generated. And then I like to organize it by type just so I can see it a little better. So notice these are CSC files that they made, and it's pretty much equivalent to a text file, but they just have CSC to distinguish it. And here's the standard that I was talking about, standard versus proposed. And I believe this is design rating, and I'm not sure how this is used. So yeah, and then other stuff in here, this is the weather file. And we have different error files for the CSC. So we can open that up just to show you, and it gives you some errors, warning, unmet heating loads. These aren't like super, like it won't break, or these specific errors aren't gonna like break the model. It's just a warning versus like an error that makes it not run. So it shows you that. And then the prop, similar. Okay. And then these are your output like Excel results. So we can look at proposed. And basically we want to look at the proposed because that's the building that we made. And then so it gives you those, it gives you hourly output for each building end use. So cooling, heating, domestic hot water, fans, all that good stuff. And then, so your report file, from my understanding, the report file will print your CSV file in front of your error messages, but for this example, it did not do that, so I'm not sure. But those are essentially the same as your error files, and we'll give you your errors as well. And then this last one here, this is a file for the domestic hot water use. basically the researchers that came up with it came up with complicated draw profiles for CBECC-Res to use. So that's just located there for CBECC-Res to reference. So, okay, back to the CSE files. We want to look at this prop.csv, that's the proposed model, and it's a CSE file. When we open it up, you can see, like that example I showed before with the define statements and different parameters of the model, like construction layers, etc., materials. It has your domestic hot water heater, domestic hot water system, and yeah. So I just wanted to show you what that looks like and where to find it within your files. Yeah, so back to the presentation. So I'm just going to present from here to make it easier. So now I want to show you how to control the CSE through CBECC-Res. So basically, when you open CBECC-Res, you need to make sure you enable research mode and click the box for report include files. So that is, so you want to go to tools and then program and analysis options. So we want to enable report include file and enable research mode. So now, when we click that, we'll be able to go to analysis. See, it didn't save. Sometimes it doesn't update quickly enough. So this is before you click it. I'm going to exit out and just open it again. So I'm going to go back here, back to my CBECC-Res file. And okay, it doesn't like that for some reason. So I'm going to go this way. So I'm going to open it up again in CBECC-Res. So now when I go to, I want to click on that project tab, the very first tab, and I want to go to the analysis tab, and now that box has showed up where it says report include file, and for the proposed only. So now we have access to that. And so how do we make a include file? So we want to, basically it'll read any text file. Most computers have Notepad on it. So that's what we're going to use. So basically open any text file like Notepad, look up the commands you want to use. I just put that step in there as opposed to just like showing you what this schedule is, and I clipped a picture here so you can see. And then look at the variable names you'll need in the CSE file. So basically, so there's different commands you can use, like I said before. And for this example, we want to change the domestic hot water system, and we want to change the set point of that hot water tank as an hourly value. And so that's a 24-hour value, and that'll be for each day of the year. It'll simulate that as that. So for example, instead of me just giving you the text file that you already need, it's like, oh, so how do I do this? I know I want to use alter. That's kind of a more high level command, basically saying alter the domestic, I want to alter the domestic hot water system, and then the name of the system, and then that hourly matrix I have there. So just to show you the CSE user manual, this is what it looks like. It's online, and it's, I think I linked that to you guys, but if I didn't, I can link it to you guys after, or give you the slides, and that has the link on it. So this is the CSE user manual. I gotta say it's not the easiest to use, but it does have a lot of good information that you need. So I know I want to change my domestic hot water system. So I'm just going to show you guys the domestic hot water system here. So here, and then it's kind of hard to explain, but the name of the domestic hot water like object within the software is this. So domestic hot water system. So I kind of looked through this, and this kind of gives you an idea of the things that you can change. So within this, I looked down, I'm like, oh, I want to change the set point temperature. And then I found this variable. So specifies the hot water set point temperature. Cool. And so now I want to use this variable name that I have here. So I'll pull up my text file that I made. So you see here I have the alter domestic hot water system. That's the object name. And then I have that WTS set point. And this hour val is also a more complicated concept, I guess. It's like a function, I guess. So it's a function that you can either put in a logical statement like, you know, if the hour is between 12 and 1, then equals 125, or you can just write out the matrix like this, or write out each number like this. Sometimes that helps me just visually seeing what's going on. So here, instead of having the default 125 for each hour, we're going to decrease the energy use from 5, or we're going to decrease the set point temperature from 5 to 9. So yeah, it takes some sifting to go through this to find the variables that you want sometimes, but I just wanted to show you the general process of that. And then also, if I want to search hour val, because I know I want to use it, but I always forget how it's used or something. They have like some examples of how to use it. Okay. So what I didn't do before this is make sure the name of my domestic hot water tank in the CSE file is actually this, domestic hot water system 1, and I'll show you how to find that. So I go back into that exercise 1 folder that I made. I go into the comp 19, and then I want to go to the proposed design. And so now I want to look up my domestic hot water tank. So I'm just going to type in domestic hot water. So here we have where it's being specified within the CSE. And this is the name of it in quotes right here. So domestic hot water system 1. And that happens to be the default name and what mine is named as. So if I had the wrong name here, it wouldn't actually change the domestic hot water system. So I just wanted to check that and show that to you guys. So now I open up CBECC-Res again. And now, so I have this file saved. Make sure it's right. Cool. Oh, not that. So this is exercise 1, right? Cool. So I want to make sure I might get this wrong right now. I want to have my include file within the main file of the within the file of the same building model. I'm going to move that into here, and that's its name. So now I'm going to go back to that tab that I showed you, analysis, report include file. I had its name was domestic hot water schedule.txt. So now that file should be in there when I run it. So actually what I want to do is run it without it, so I can record the domestic hot water. Actually, we have the analysis results from the previous run, which is this little icon here. So I'm going to look at that. So energy use details, what we had before. I'm just going to write this down. So where are we? Water heating. So this is all in TDV. That's kind of another discussion. 14.15. Oh, that's the standard. Okay, so I want to look at the proposed column. So 26.6, and then it's a negative 12.45 compliance. So hopefully we want to change that with our schedule. So now back to the analysis tab. See if this works. So we had an error. So let's view those errors. So it didn't like the name. Oh, I see. And I didn't catch that. System. I think in our CSV file it was named system, not just SYS. So now I save that. Okay, save it again, and now we want to run. So it's kind of nice, it gives you errors, and you can correct it as you go. Let's see if our energy has changed. And it's the same. Okay. So let's backtrack and make sure we have all the information. Okay, it's in there. Cool. So, way to see if it's working or if it's reading the file, we can just change it to a ridiculous number. So instead of the hour val, I'm gonna make the set point like, it might not like a super high number, maybe like 200. So theoretically, that would change the energy use of the hot water heater, and we would see that result. So we save it. So I guess we know it's reading it in because it gave us that error before. So maybe just the schedule I had wasn't different enough. And again, it's not changing. So yeah, sorry guys, I should have tested this before. But that is the general format, I guess. It should change it, theoretically. So I'm going to double check that name again. The name of the system. Okay. Okay. All right, let's move on. That's the general way you want to change it. And again, like I said, it was reading it because it gave us an error. So that's that. So a more simple way, maybe, is, so like I said before, there's two different ways we can control the CSV. one was through CBECC-Res, and where we have this include file that we have here. So instead of doing that, we can just edit the CSE, but instead of running it through CBECC-Res, we're going to run it through the CSE launcher. And again, you need to use CBECC-Res first to just generate those files that I showed you, and then you can go in and edit it and then run it through the CSE launcher. So let's see if I can get it to change through here. So just going to open that up. It's basically just this little program that runs the CSE file. Hit those dots. Now I want to go to exercise 1. I want to go into my comp19 folder, and I want to find that CSE file, that proposed.csc. Cool. So now it should run. So now I'm going to delete this file, this text file that we made, so we no longer need it. Well, instead I'm going to move it out here so I don't lose it. So exercise 1. So now we're going to open that prop.csc file again. So now let's go to our domestic hot water system again. So we're here at the domestic hot water system, and so here's that set point temperature value that we were trying to use. So basically you can use the same language that we did here. See, that's this being specified in the CSE file. So here we're saying, oh, alter the domestic hot water system, go into that CSE file, and then change this variable. But now instead we're going to go in and change it directly. So let's make it 200. Well, what was it before? 125? I don't know. Or was it? Yeah. So let's run it without changing anything first. Okay, so it didn't like that for some reason. So it's saying I clicked the CSE launcher, I clicked run, and then it gave me, gave me this output report saying, oh, the CSE did not run successfully. And it turns out, since I didn't delete the domestic hot water schedule text from the CSE language here, it didn't run because it couldn't find that file. So typically where it'll copy it in. Okay. So basically when we put it in CBECC-Res copied it into the CSE file and then ran it. Sorry if that's a little confusing. But here we're going to change it directly. So we're going to, okay, so it added it at the end. So basically we told CBECC-Res to include this file. So it copied it into the CSE language. So now we want to delete it out because we no longer have that text file. Okay, so now we want to save. Let's run it again. So now it's working. Cool, CSE ran successfully. So now to look at the results of this, we can go into that exercise 1 file, go into the comp19, and then look at that Excel file that I showed you. So this shows the energy use, and it's in kilobtu's, I believe. So this is a little wonky, but so I want to let's look at domestic hot water. see how much energy that used, and then we'll change it, and then see if it changes. So I want to sum this whole column, so it's 0. You know, I may have chosen a too simple model to show you guys because it might not actually. Okay. Let me check something. It should be using energy, but it's not. So that's interesting. So let me show you a more complicated model, I guess. Let's see. Well, maybe one of these. Just bear with me here. So again, we're starting off with just the CBECC-Res file, so I want to open that up. So you can see this has more details within the model. And let's run it. So basically, it's just running the proposed model. Okay, here we can definitely see that we have some energy used by the domestic hot water heater. So that's a good sign. Okay, so let's get rid of this guy. So basically I ran exercise 7 and I'm looking at its baseline use without changing anything. So let's see how much energy this uses. So 6508. Cool. Don't save. So now since I ran this model, I don't need CBECC-Res anymore. So go into Comp9 folder. I'm going to go into the CSV file. And I'm going to find the domestic hot water again. Okay, so domestic hot water system, set point 125. Let's change that to 200. It's heating up. So now I want to find this file. Go to the desktop. prop.csc, open. Now let's run it. And it's working. Cool, so that looks like it worked. Now I'm going to open up that Excel file again, which just is updated by this new parameter that we put in. Now let's see, look, how much harder it's working. Before there's like some blank spaces. Yeah, so it's way more energy than before. Before we had about 6,500, and now we have like way more energy, which is what we should assume because we changed the set point temperature to a much higher number. Cool. Well, I don't want to save that actually. No way. Cool. So yeah, so that's how you use just the CSE. So now that we actually have energy use in our domestic hot water system, I can show you that include file again, but hopefully correctly. So let's make a new, well, okay. So here's our domestic hot water schedule again. Let's throw it in. We want to change it to 200. CBECC-Res again. Open exercise 7. See, this example already had an include file. These are the other training that I went to example. So I'm gonna make our schedule.text. I guess, okay, previous results, right? Let's look at those. Water heating, 31.75. So now we changed it. I'm gonna double check. Cool. Now let's run it again. Whoop, it's just telling us to save. So basically, so like I showed you before, we went into the CSE file in example 2 and changed it. But now we're going back and using CBECC-Res to change it. So if we didn't put any include file or anything, CBECC-Res would overwrite everything you just changed in the CSE. So that's why you have to use the CSE launcher or the command prompt to run the model. Let's see if it changed. Oh yeah, it changed by a lot. Before it was 31 and now it's 74. So yeah, there you go. And yeah, that's pretty much the only example I wanted to walk through with you guys. Just showing you how you can use the CSE through an input file and then also going directly into the CSE language and changing that, then running it through the CSE launcher. The next few slides are some other examples. So I also sent you guys, sorry, that's my cat. So just showing you guys some other examples and resources. I kind of showed you guys a complicated example just to dive right into it. If I was going to give a longer form discussion on this, I would probably start at the bigger picture and really go through each definition and like each parameter in the CSE file. And that would require more preparation on my end as well. But one of the resources I showed you guys was the CSE cheat sheet. So let me open that and just show you what that looks like. And this was prepared by Big Ladder, which is a, I guess, a software development company that works with the California Energy Commission to maintain and update CBECC-Res. So they're a pretty cool company and they hold various trainings, which is pretty cool. So for the CSE cheat sheet, kind of just shows you some more general information. So in general, what I showed you, when I showed you the domestic hot water system, the class, I guess, would be the domestic hot water system, and then you have the object name, And then you have different defining characteristics or data members for that class, which is the set point was. You can see this structure replicated in all the other objects and classes. So basically, there's a hierarchy to these different items within your model. So we just looked at the domestic hot water system, which is down here. But basically, you want to start with your top defining things, and then you want to go into your construction layers, then you want to go into your zones, then you want to define your HVAC system, and then your domestic hot water system, and so on and so forth. So that kind of like lays out what's in the file. So the preprocessor is what those define statements that you saw. Basically, those are different statements that you can make that happen before the model is run. That's kind of like a very overarching description of what it is without showing you guys what it actually does, which is more complicated, but just know that you can do that. Like you can define a variable up top that'll change something within later on in the code. So you can basically just go to the top and change that variable. For example, it's probably not the best description, but yeah, so different expressions you can use, like basic addition, multiplication, all that good stuff. And then you have like logical statements. Like I said before, how we specified the hour val or the temperature in the tank, we could have used like different logical statements to make that as well, like less than or greater than and that kind of thing. And then it gives you some system variables that you can change. So these are kind of like just overarching parameters, I guess. Yeah. These are different, like for example, within your weather file, you can basically record these different items that are within the weather file that the CSE is reading. So for example, the outdoor temperature, if I wanted to record that, I know the CSE is tracking that variable, so I could like print that out somewhere else later, for example. And like this is just giving you a snippet of like what you can record. That's why the user manual is so helpful, because it's like, oh, what variables can I even record? I want to get this information out, but does the CSE actually track that? And then there's some other built-in functions, which is like the hour val that we were talking about. For example, it from a list of 24 values returns the value corresponding to the hour of the day, effectively defined 24-hour variation. So there's different variables that you can assign that variation to, but not all of them you can make a 24-hour variation of. But for set point temperatures, usually an hour val, or you can give that variation over 24 hours. Like it's pretty common with thermostats, like doing a setback temperature or something like that, like during the day. You want to, for example, make your building a little warmer, so you increase the set point temperature during the middle of the day when no one's in the building, but when people come back at night and it's still warm outside, you can tell your thermostat to turn back on and decrease the internal temperature of the house, if that makes sense how I'm describing it. And then probes are a way you can get out information. And here are some examples of probes. Woohoo! Like for example, I want to say in this zone, at this zone, I want to record the temperature. So that's useful. And then input statements. These are the only input statements for the CSE. So we use that alter statement, which is super useful. You can copy things, and then you can use this run statement, which is also useful if you want to run the CSE multiple times. Like say you had multiple schedules, you can have your first schedule, which is what I showed you in the input file, and then put run after it, and then a new schedule, so it'll run it twice, run the CSE file twice. Yeah, that's a lot of information, but that's kind of just a sampling of what the CSE can do. So yeah, that's a good resource. Sometimes it's hard to get all the definitions of these different things. That's why jumping into an example can be useful. And then to end off, I guess I wanted to show you some more complicated input files that I have used in the past to do certain things. So the first one, let me just full screen this. So the first one, for example, I was trying to simulate a power outage. So basically, I wanted to tell the HVAC system and then the fans to turn off for a few days. So how I did this, this is the input file. So I have that alter statement again. So I'm altering the zone, and it's zone 1, the only zone in the model. And I want to tell the set point temperature to basically increase those few days to a super high number so the HVAC system doesn't turn on. The premise being that during the power outage, it's also during a heat wave, so it's really hot outside. So your AC would be running. So basically, I set the indoor temperature to 150, as you can see right here, basically making it so the AC system never turns on during those few days. So the zone temperature equals basically, so the select is like the hour val function. You can use it to do different things. So I'm saying, okay, if the month is 7 and the day of the month is greater than 13 and it's less than 27, I want the set point temperature to be 150, and then the rest of the statement is kind of default. The rest of the statement here is default stuff. So this is defining the design days, what temperatures are appropriate for that. And that's, you know, a default that was used in the software before. I didn't make those up. And then, so basically use these temperatures for design days, and then the default hour val, which is that hourly profile that we were talking about, will be this for the rest of the year. And then, so that's just for the zone set point temperature, which is what I changed here. I altered the zone to do that. So now I wanted to turn off the fans. So there's 2 different fans. There's a whole house fan and an IAQ fan that's default, indoor air quality fan that's default within the software. And I wanted to turn those off. So again, using the alter. So I want to alter. So basically, IZXFER means interzonal, like, flow or something, airflow, I think. I'm not getting that definition exact, but that's what it means. So alter this interzonal flow, which is the name, the name of which is the IAQ fan. Basically, same kind of logic. If the month is 7 and the day is greater than 13 and less than 27, I want like a really low number so it doesn't really come up. The energy use isn't recognized because it's such a low number. And then same thing for the other fan. So it kind of, it's kind of difficult to come up with these different numbers. You gotta like I said, sift through the CSE user manual, find the right parameter. Okay, let's change this, and like let's put this logical statement on it so it doesn't turn off for these hours, and so on. Yeah, and then another example that I have, which I think is a pretty cool, powerful tool, You can customize reports that you output. So those Excel files that we were looking at, we can basically come up with our own Excel files that it can output, which is useful. Like in this example, I wanted to output certain values, and then I also wanted to do a calculation in the output. So basically it calculates it for me in the CSV and then outputs it to a file. So in this one, I was tracking the zone wet bulb temperature, the zone dry bulb or air temperature, the zone relative humidity, and then the zone discomfort index. And that index is calculated by this equation up here. Pretty simple equation. But basically, I want to calculate this within the CSV language. So I know that the software records this dry bulb temperature, and I know it records the wet bulb temperature. So I want to find those variable names, and I want to basically do this calculation. So just to like briefly go through this, sorry if this is overwhelming amount of information, but it's just to show you what the CSV is capable of. So we have an export file. Basically, we're specifying, oh, we want an export file, and we want a results, and we want a CSV file. So these are parameters that you set up, basically saying, oh, hourly through these dates, and we want a month, day, and hour for each column. And then here's where we record the values that I was talking about. It'll help if I wouldn't delete the image. So I want the column name, zone wet bulb temperature, and then I want a value in that column, which is the zone temperature. And this is an example of a probe. So I want to go at the zone 1. I want to record the wet bulb temperature. And then it's the same for the dry bulb, or they just call it the air temperature. And then we have relative humidity, which is something I was recording, not using for the calculation. But for this last column that I wanted, I want to do this calculation that I showed up here. So I can actually put in that logic and it'll calculate that. So then when I run this file and the building model, it'll export all this information to an Excel file that I can use. It just kind of makes it one step easier. So yeah, that's pretty much what I wanted to show you guys. I know that's a lot of information, but that's pretty much the end of what I wanted to say. So if anyone had any questions, feel free to ask them now. Cool. Well, yeah, so maybe if we want to continue on this education journey of how to use this stuff, I can give you guys examples and then different input files that you guys can make, that kind of stuff.
Cool. Thank you, Emily. I have a question.
Sure.
Which do you prefer to use? Do you like to use the input files from a notepad, or do you like to use the hard coding something into CSE?
So for this project, these two more complicated input files I showed you, so I had like multiple things going on, so I wanted multiple text files in my CSE input file. So I did just go directly into the CSE file and then input a few different text files. Just because from like the surface level of CBECC-Res, you can't put in like more than one text file. So yeah.
And do you have a way of I guess controlling the CSE file that you have as like a master file so that you can always revert back to the original settings?
Right. Yeah, so that's pretty important, and that just goes to like file saving. You make sure you have like the right stuff, or make sure you're saving periodically, or if you want that original file, make sure you save that. I mean, that's why it's kind of easy, sometimes easier to use a text file, because then you know all your changes are within that one file. So you can go in to the CSE and just delete where it's saying, oh, use this text file. So then it should have all the parameters.
Gotcha.
Yeah, because you can go in like how we did. We went into the file and we changed it to 150. So that's like hard coding that 150. Now it's like online like 500, and now we can't find where we had it. So instead of doing that, we could use that text file instead. So now, you know, in the original file, it still has that 125, but we're just like altering it with a text file. So our changes are made like externally, I guess, if that makes sense.
Yeah. Cool.
Yeah.
Well, yeah, I
So,
look forward to going through more of these trainings. And if you go through like some step-by-step how to do it basics of actually like opening up the file and doing some different functions, that would be really fun.
yeah, we could, you know, I could be more prepared, and we could all do it at the same time, I guess.
Yeah,
And then I
in
can,
person might be really helpful also for that. But
yeah, definitely.
yeah, I look forward to learning more. That was cool. Thank you.
Yeah.
Yeah, thanks, Emily.
Yeah, cool. Thanks for listening, guys.
No problem.